We're going to start our day with a talk from Cameron Pittman from Udacity. Give him a big round of applause, please.
Thanks, everybody. First off, I have a request. If anything heavy is about to fall on me, please let me know. I don't want I like it here. I just don't want to die here. OK, so anyway, thanks for coming. Thanks to the whole SINFO staff for getting this set up. It's really amazing seeing how excited that everybody is to get into tech and get into the world outside. First off, there's a funny story, actually. So I was looking online at videos of last year's SINFOs, and I actually found out I'm the second person from my high school to speak here. Last year, you guys had Jessica McKellar. She's big in the Python open source community. She and I actually went to high school together. She was the valedictorian of my class, so it's kind of funny. Anyway, I'll be talking today about lifelong learning. And I'm really excited because it's a topic that's very near and dear to my heart, and it's also why Udacity exists. Cool. OK, so hola. I hope I said that right. Right now, I'm a software engineer for student services at Udacity. Student services is responsible for any app that connects people, well, really students, with other people as they're working. These are graders, these are mentors, and I'll be talking more about that later. Before that, I was a content developer. And a content developer at Udacity is basically a teacher. We make classes. We do everything that we have to do. We script them, we outline them, we decide what the curriculum is going to be. We work with industry experts, we build projects, we put it all together, we film it, and it's a crazy, crazy job. But it was a lot of fun, and I really enjoy doing it. And I did that with web classes and self-driving cars. Before that, keep going back and back in my history, I'm a self-taught programmer. I taught myself how to code about 5 years ago. So I'm really excited, even more so excited to be here today. And even way before that, my first job out of college was a high school teacher. So I'll be talking a little bit more about that, too. You can find my blog and my Twitter up there. Neither one of them is on topic. I very rarely even talk about the web. I mean, I do sometimes, but mostly it's about space and books. Those are like what I like doing, and my side projects. OK, so the title of this talk is Scaling Impact-Driven Education. And I pulled that from our values. These are the Udacity values that we use to decide how we want to work, how we want to act, and what we want our company to be. The first one on there is students first, and this is our oldest value. We change them over time. You can actually, if you ever visit the Udacity office, you'll see this painted on the walls in different places, in prominent places, because it's so important to us that students are at the top of our mind for every decision that we make. We also have audacious and humble and better together. My laser pointer doesn't work, but those are on the corners. Those basically tell us, as Udacity employees, how we should work. Woo! Give it a sec. And then the last one is impact-driven. And impact-driven means that we're going to prioritize the work that we do, the energy that we put into it, and our behavior such that our results are as meaningful as possible. And that's what I want to talk to you guys about today. OK, so this phrase, I think, is why Udacity exists. We like to think that anybody around the world is equally, has the equal chance of being intelligent. Anybody can be smart. Anybody has the potential. But it's not true that everybody has the opportunity to use that potential. For instance, if you're born, let's say, in Palo Alto, California, or New York City, or London, or Lisbon, you're going to have people and places around you that can support you if you want to get into tech, right? There are people in tech. There are conferences like this. And all of those opportunities will be helpful for you. Can you guys even hear me? Give it a sec. All right. Hopefully you can hear me. All right, anyway, so I also believe this is true for ourselves. I'm just going to talk louder and probably blow out the microphone, but that's all right. I think this is also true for ourselves. I think that all of us have some kind of talent, but not all of us have the same opportunity to express that talent. And so I think that Udacity exists so that both individuals and communities can use their talent to the full potential. The fact of the matter is that the world is changing. 2 years ago, we had about half the planet online, and I'm sure that number is higher now. We want to make sure at Udacity that for every person that comes online, they have an equal chance of benefiting from the internet the same way that the first 3.5 billion people have been able to benefit from the internet. We also know that the world of industry is changing. According to Gartner, which is a US research company, by the year 2020, which is only 2 years away, it sounds futuristic, but it's really not. Artificial intelligence, is going to eliminate about 1.8 million jobs and create 2.3 million more. Of course, that's a net gain, but there's still going to be a lot of thrashing. People are going to be losing jobs, and jobs are going to be popping up in ways that we don't expect. Already, you see manufacturing jobs disappearing. You see truck driving jobs disappearing. And I really don't think we're that far away from white-collar jobs disappearing, jobs like accountants or even programmers one day. It's really not hard to imagine that artificial intelligence could be replacing us all. So we need to stay on top of our game, otherwise we're in trouble. But it is true that artificial intelligence is helping us, right? It gives us insights that we couldn't have otherwise. And it's also true that 4 years of study, or 3 years, I think it's 3 years here, is that right? 3 or 4, 3? 3, okay. 3 years isn't enough, or 4 years. At the start of your career is enough. And the point is there that you're not going to be able to learn everything that you need for a lifetime in just a couple years when you're in your late teens and early 20s, right? Like it's kind of ridiculous when the world is changing so much. I mean, it's hard enough nowadays to just read like hacker news and keep up with it. There's so many new technologies popping up every day. It's hard to imagine what you even will need to know just a few years from now. So we all need to keep learning. So I'm going to use a case study of myself. My story, begins right after college. Today I'm a software engineer, but back then I was a high school teacher. And looking back, I've tried to make sense of it. It felt chaotic, but I want to draw some learnings from it that I can share with you guys today. All right. So this is me. This was, I guess, 5 years ago now. Teaching. I was teaching high school physics and chemistry and a few other sciences in an inner city school in Nashville, Tennessee, which is a small metropolis in the United States. It's a fun place to live, actually, if you ever get a chance to visit, but that's besides the point. Anyway, teaching was really, really difficult. And one of the hardest things about teaching was getting lab supplies. My class was a class that we didn't have standardized tests at the end of the year on, so I could basically do whatever I wanted, and I want to let spontaneity guide my labs. The problem was that it took about a year to go through my school district to get new lab supplies. It was a nightmare of a bureaucracy. And so I wanted an easier way to do fun labs on the fly, like come up with the lab yesterday because one of my students asked a great question, and today we've got this awesome lab that I didn't even think of before, and I just couldn't do that. But I did realize that, okay, well, if I had a physics simulator, if I had a flexible physics simulator that I could use, well, in that case, I could have some fun with the labs. We could do something. So I thought, all right, well, what's an easy way to get a physics simulator? And I realized that the most common physics simulators are video games. Modern video games have physics engines. Physics engines dictate the way objects move and react in the game. And the more realistically that they move, the more realistically they follow the laws of physics, the more realistic the game seems. And so a lot of video games have very realistic physics engines. And then that very quickly led to the video game Portal. How many of you guys have played Portal? A bunch? Yeah, not everybody though. If you haven't played it, you should. It's a great way to feel like your brain is just getting ripped out, but you're getting smarter at the same time. It's a great game. But I had my students using this game to learn physics. And let me show you what that looked like. So this is a video from one of the labs. Well, I actually made a bunch of videos like this to showcase what I could have my students building in the game and how they could be learning with Portal. So what's going on here, you see these cubes flying. There's a portal or a wormhole on the ground. The cubes fall into the wormhole and then shoot out of another wormhole on the wall at different distances. And you can actually see the lines here. I was having some fun with it. That's basically a ruler on the ground to make it easier to measure how far they're going. But I had my students building labs like this and then comparing what they saw to what you would expect to see if the laws of physics were applying. And as it turns out, the game is pretty accurate. There are a few quirks, though, and that was part of the fun, is getting students to figure out what the quirks were. So, taking a step back, all right, I decided I wanted to build some labs with Portal. I wanted my students to use it. So I went to the internet to get help because I needed a bunch of copies of Portal. So I went to Reddit. I went on Reddit and I was like, hey gamers, can I have any extra copies of Portal? You guys have any? Because for a while it was being given away for free, so I figured there might be at least a couple dozen people online that might. And it turns out there are, and they gave me them, which was amazing. But I also got a response back from the video game company Valve that made Portal. And the people at Valve told me that they were really interested in educational technology and they wanted to see how their game Portal could be used in an educational way. And that turned into a pretty amazing relationship. I got to know some people there really well. Over the next couple years, we worked together on a few different things. They sponsored me to go to conferences and do outreach with other teachers to show them how they could make an educational experience in Portal. In fact, it's not even just limited to physics. I know English teachers that were using it as well. It also created some other opportunities, like they even filmed a documentary about my classroom. It was unreleased, unpublished, you can't find it. That's where that last screenshot came from, actually. And then later, one of the people that I met at Valve left, started her own company, and asked me to join her. So it created this whole new career that I didn't expect. And I wasn't looking for a new career, I was just looking to solve a problem. All right, so this is sort of this framework that I've mashed together in hieroglyphics to explain how you might be able to improve yourself in a scientific way. All right, so the first part is finding problems that you love solving. For me, when I was teaching with Portal, this was just the idea of how do I take this crazy idea? How do I take this crazy idea and make it a reality? How do I teach physics in a way that nobody's ever done before, in a way that's obviously useful to students? And of course, you need to love it, because no matter what you're doing, if you're trying to improve yourself, if you're embarking on lifelong learning, there are just too many problems out there to stick with the problem that you don't love. Find something you do love, and you have so many options. And another reason you want to love it is because you're going to be spending a lot of time with it. You're going to need to study. So if you have read the book Outliers by Malcolm Gladwell, he says that you need 10,000 hours to learn a new skill. I did the math. If you study for 8 hours a day, Monday through Friday for a whole year, that's just over 2,000 hours. So I'm at just about the 5-year mark of programming. So I'm like close to being able to say that I've mastered it. I don't know if that's true, but I might say that from now on. But the fact of the matter is you're going to be spending a lot of time with it. And then you need a network. So I got lucky when I was working with Portal. I got to meet some people because I went out and asked questions and found some people who were interested in solving the same problems as me. And unfortunately, for the idealists among us, the phrase, "it's not what you know, it's who you know," is true. Behind every successful person, there's a whole network of successful people behind them helping each other out. And of course, nobody is a success just by themselves. The thing is, though, that network gives you a chance to explain to those people what you know. It gives you a chance to show off what you know and then get opportunities. So you guys are actually doing a great thing today by being here, because conferences like this are a great way to network. And then lastly, there's the option of taking the leap. You may find yourself in a position where you want to know, should I leave my company? Should I leave this career that I know well and jump to do something new? Do I quit my job to start an app? Do I quit my job to start a company? Do I think that because I've created this great relationship with this company that they should hire me, so I should just email them and tell them to hire me? I actually did that one. It kind of worked. But the point is, you're going to be facing these questions. And when you do, I like to play a game called the 90-year-old regret game, where you ask yourself what you'll be thinking when you're at the end of your life, laying in bed, thinking about the decisions that you made. This is hard to say. What will you then wish you would have done now, right? What is that person thinking? Whatever they're thinking, that's what you should do. And it's maybe not necessarily that easy, but I think that's a great way to find the answer. So when I started in the startup world, when I left teaching, my lifelong learning really began in earnest. I was the second employee at a company. I had the title director of content, but that meant nothing. I had no idea what my job was. I didn't know what I was supposed to do. I'd never been in a company before, let alone been the second person in a company. And so I had to figure out what I was doing. And luckily, you can learn anything on the internet. It's fantastic. It's not just for cute puppy pictures, but I do have some in here because it actually is for cute puppy pictures. So I started learning. I went online. I read books. I read The Lean Startup by Eric Ries. I don't know if you guys have read that before, but it's an amazing book. Not just about how to create a business, but how to create anything that's useful for other people. And I also realized that it was really, really silly that I was working for a website, but I didn't know how websites worked. This was, like I said, before I started to code. So I started learning, and I just became absolutely obsessed, probably to an unhealthy degree. I think my girlfriend at the time probably would have said that I was unhealthy about it, but I really enjoyed it, and that's all I thought about. And I started learning how to code with a couple different resources. I used ThinkPython, which is a book by Alan Downey. And I also used MIT OpenCourseWare, which is some MIT classes that are available online. And what I really found was useful was doing the exercises, doing the quizzes, the tests, what have you, and then putting my own spin on them. For instance, let's say there was an early exercise that had me multiplying two numbers. Well, I'd say, like, okay, well, I can multiply. There's that star operator to multiply. Like, all right, well, how would I do an exponent then? And so, maybe I look up, like, how do you do an exponent? Oh, look, there's a caret character, the little hat. Or maybe there's a math library to use. And I just sort of picked up these little things over time, but I was doing it on my own, and I was excited about it. And I'm actually still proud of some of those early projects, and let me show you one now. All right, so this is one of the first things that I built when I learned how to code. It's a physics simulator, of course. There's a theme here. My major was physics. I don't know if I mentioned that. What I was doing here was I was learning how to use a graphics library called Cinder. Cinder's for C++. It's for 2D and I think 3D graphics. And I was doing a tutorial. I was putting some shapes on the screen, and I thought it was really neat that I was putting shapes on the screen, but I wanted to extend it. So I decided, okay, well, if I want to extend it, I should make them move around, and hey, let's put some physics in it, because why not? So what you're seeing here are these stars. Those are those circles. The stars are moving around this field, and you can see these vectors. The arrows are vectors that show the strength and the direction of the gravitational field at every point. It's not super accurate. There are a few obvious problems. One is the stars don't interact with each other. I wasn't that fancy. Second is that the arrows get way too long for no apparent reason. Well, I mean, I know the reason. I didn't fix it, though. But they get way too long, and sometimes they disappear, which is kind of funny. But regardless, I got to build something that I was so proud of. And in fact, when I first interviewed at Udacity, this was actually just a few months after I learned how to code, they asked me, because they knew, I just learned how to code. They're like, okay, so what have you built? And I actually pulled out my old laptop and showed them this. And I was like, look, I built a physics simulator. And I was so excited about it, showing the same kind of passion that I still feel about it today, that I'm 100% confident that that's the reason I got the job. And this is another lesson. Everybody who's interviewing you wants to know that you want to solve the problems that you're going to be solving at that company, right? It helps to be passionate about what you want to do. So this is all the more reason to find problems that you love solving. I'm still learning today. We're really excited about the programming language Go at Udacity. We're using it for a lot of our back-end work now, and it's a lot of fun. Right now, on the side, I'm building something to upload files to something called AWS Glacier. If you're not familiar with Glacier, Glacier is basically cold storage for files. It's where you can take huge files that you don't want to access and just leave them for long periods of time. What I want to do is actually upload all the video from the documentary. I have about a terabyte that I don't want to lose. It's sitting on a spinning disk hard drive that's, they could die at any moment. So I want to get it up in the cloud. But this is giving me an opportunity to perfect a few things that I've really only learned kind of in theory, but I haven't been able to practice them as well as I want. One of those is memory management, because you can't load a terabyte into RAM at once and expect your computer to not blow up. And also, I want to get better at TCP connections. And I know the theory behind TCP slow start and congestion windows, but I haven't really been able to apply it that well. And this gives me a great opportunity, because understanding and using TCP well means the difference between files that upload in a few hours versus files that upload in a few days. So I want to do it right. And this is giving me an opportunity to do so. And that's just the UI I'm playing with it. I figured that was more exciting than just some random code on the screen. Anyway, okay, enough about me. I want to talk about Udacity. So Udacity is all about helping people with their lifelong learning. To give you an idea of what this looks like today, I'm going to go over what one of our nano degrees looks like. And how many of you guys actually have heard of nano degrees? A couple of y'all? I think there are a few students, right? Woo! Yeah, that's awesome. All right, so you guys will already know a lot of this. So this is the syllabus for our self-driving car nano degree. We offer a lot of nano degrees. These are basically programs or collections of projects and classes, all designed to usually help people get a job. They range from everything from intro to programming to now we have flying cars, actually, as a nano degree. Learn basically the programming that goes behind drones, which is really exciting. But we also have non-technical nano degrees, like on digital marketing. But this one is self-driving car. And there's one thing I want to point out here is that there are a lot of projects. There we go. Yeah, there are a lot of projects. For this nano degree, there are 15 projects. In these projects, students submit their code, and a real person gives them line-by-line feedback on their code. This is good for a lot of reasons. Obviously, it follows the same philosophy that I felt, that I used when I was learning. But it's also great for some reasons I'll be talking about in a few minutes. All right, so let's dive into one of these terms. There are 3 terms here: computer vision and deep learning, sensor fusion, and then path planning. Let's dive into one, and we can see some smaller lessons. And we know that one project every once in a while isn't enough, so we break it down, and we have a lot of ungraded assignments. These are basically chances for students to show what they've learned as they're working, but they're really just working for themselves. In this case, there are 2 here. We have one called MiniFlow. That's one that I built. In MiniFlow, students build a neural network from scratch with Python. And then later, in the next one, they use TensorFlow, which is Google's deep learning framework. Of course, it helps to do something the hard way before you do it the easy way, so you really appreciate the hard way. All right, let me jump into this and wait for the wind to die down. All right, anyway. So this is a quiz. These assignments are broken up into even smaller quizzes. We want to keep students active. We want to keep them moving. We have quizzes of different types. We have some that are just multiple choice questions and others that are actual programming exercises right here in the classroom. In this quiz, students are actually adding to the neural network. They're adding a feature to it. And yeah, it's a lot of fun. But I want to stop here and mention something called differentiated instruction. This is the idea that teaching, what did I press? Oh, okay, I'm good. Teaching is really hard. Teaching is incredibly difficult, and it's even more so online. And differentiated instruction is one of the reasons why. Differentiated instruction is the idea that you can create a lesson for a whole range of learners. These are people who are advanced, intermediate, beginner, or perhaps these are people who are auditory learners, or visual learners, or people who just like to read things, or people who learn, or tactile learners, learn with their hands. You should be able to create a single lesson and then make small changes to it so that everybody can learn from it. And one of those ways that you can make changes is just by letting people go at their own pace. And luckily, online, anybody can take and retry and reread and rewatch and retry things as many times as they want. So that helps out a lot with differentiated instruction. But there's still a lot of work that we need to do. What's funny is that with our classes and with our quizzes, we get almost equal numbers of responses like this. Some people saying that, wait, this is way too impossible. How could you possibly expect us to be able to do this? And then the same number of people saying, like, this is too easy. Why am I even here? So we still definitely have a long ways to go. But we've been using modern research techniques and trying to figure out ways to get people addicted to learning and keep coming back to the classroom. And I want to show you something that we recently released. This is something new. This is called a lab. Let's see, is that video playing? There we go. Something called a lab. We actually released this feature last week. It's in our front-end nano degree. It's really exciting. You can see me here working in an IDE in my browser. And then on the right side, we actually have a virtual browser where you can see the site updating as I work. So I just uploaded a picture of my dog. You're going to see her show up here in just a second. And you can tell it's refreshing. You can tell it's live because it's refreshing as I'm typing. That's Hawkeye. She's adorable. She's 2 years old. Anyway, so as I'm working, you can see students. It's not hard to imagine students getting feedback immediately as they're working. Here, let me show you what that looks like in just a second. So I finished making changes. I'm going to click Run Code. And right here in the classroom, we're going to give students feedback about their work immediately. It's pretty amazing. There are also GPU-enabled versions of this that will be released very soon. So if you're taking our virtual reality classes or self-driving car or machine learning classes, you'll be able to actually build 3D shapes in your browser. You'll be able to train machine learning models inside your browser, inside the Udacity classroom without leaving, which is really, really exciting. I actually have thought, like, hey, maybe I should actually go back and make some of these and stop doing this silly software engineering. I don't know if that'll happen, but maybe. And anyway, so at the end of the day, where does this all end up? And for us, with self-driving car, this ends up when students are actually putting their code on a real self-driving car. It's pretty exciting, and I have a video of that. So this is Team Vulture, which was the first team to finish the self-driving car nano degree. And of course, no one person can actually program a self-driving car by themselves safely. So this is a team of people. They're driving around in a car that's running. They're not driving right now. They're just passengers letting the car drive itself. I don't really know what to say here. I just think this is an amazing moment in education where people, diverse people from a huge array of backgrounds can come together online for something as amazing as making a car drive itself. Oops, I'm breaking this thing. Making a car drive itself. So I was just really thrilled to see it. Also, Carla, in case you're curious, that's the name of the car. I helped name it. I think it was my decision. I don't want to go on record saying that, though. It might have been somebody else's, but I was in the meeting where it happened. All right, anyway. So how did we get here? How did we get to this point where we have students building self-driving cars? And the answer to that is the same way that any company gets anywhere, which is experimentation. We've had a lot of successes, but also a lot of failures in our past. So I want to walk you guys through a quick framework that basically shows you how we like to learn as a company. So this is our classroom in 2012. This was basically the original Udacity classroom. It was built for Sebastian's style. I don't know if you guys have heard of Sebastian Thrun. He's our CEO. He's like a mild tech celebrity, a little eccentric. He's a cool guy. And there's a lot to love about this classroom. He's got an amazing teaching style. On the right side of the screen, you can see the list of what students are basically doing. You can see videos and questions and answers. And we were keeping students busy back then, too. We wanted to make sure that students are applying what they've learned as much as possible. We also had these tablet videos. So if you guys have ever taken any of my classes, you've probably seen my hand in that same pen on screen. It's fun. They're really fun to make. I really enjoy making them, but we don't make them anymore. They're expressive and dynamic, and also next to impossible to localize or translate. It's easy to translate the audio and get subtitles at the very least, but that handwritten text isn't going anywhere. Those are basically pictures, and it's next to impossible to translate pictures, at least at the kind of scale that we have. I mean, we have like thousands of hours of video, so it's just not going to happen. So we don't make these anymore, unfortunately. We still have videos, but we use them more to show concepts, but not introduce new material. And then the last thing I want to point out here is the title of the course, which is Stats 101. The first focus of Udacity was on basically making a university online, but things have changed to jobs. These are Lego people in jobs, or, you know, anyway, they're all yellow. It's kind of silly, but I like them. Lifelong learning is about preparing people for the future, and if so, we need to prepare people for the jobs of the future. Not everybody who's taking a Udacity class wants a new job necessarily, but it really helps us focus our curriculum. So, one way that we focus on jobs is with the projects that I've talked a lot about, that give students a way to create a portfolio to show to employers, hey, this is what I can do, check it out. Like if somebody asks you, you're sitting across the table from somebody and they say like, okay, why do you belong here? You say like, look, because I can make these amazing things that you guys make, right? Like it doesn't get much better than that. It's a very powerful message. And it also gives us the opportunity to track something. Everything that we do funnels into jobs. That's a very terrible funnel that I made this morning, but it's a funnel. And we know when we're measuring how many students are getting into jobs, it tells us what's creating the most impact. All right, and you can see this all over our website. This is our self-driving car overview page, our nano degree overview page, and you can see that we made it with industry. We worked with amazing companies like Mercedes and NVIDIA and Uber and Didi and BMW and McLaren. It's amazing that they've been able to have such a strong influence over the courses themselves. They're really fun to work with, too. I got to work with some people at Mercedes. It's a great experience because these people usually don't have a lot of influence over what's happening in a classroom. And here, now they basically get to say, this is exactly what's happening in a classroom because it's really useful for them. It also means that we get to ask these companies, what will impress you when somebody is sitting across the table from you and applying for a job? We ask them that literal question, and their answer is what we put into the classes. Those are the projects that we make. We also have a conference every year. It's called Intersect, and we try to connect our students with employers there too. This year, it's in a couple of weeks, we have more than 25 companies who are going to be looking to hire our graduates and students. All right, so this is the general framework, once again, in emoji form. I love emojis. Right now, I'm actually involved in an experiment, so this is something that I've been thinking a lot about. But the first part of an experiment is the same as the first part as a scientific experiment. You want to make a prediction. You can't just do something and then after the fact say whether or not it was successful. You need to make a prediction. You need to say, this is our objective, these are our measurable goals, and this is when we want to know the answer by. Then you do that thing, and then you observe. And when you make your observations, you look back at the predictions and say, like, did we meet our goals? Were we able to achieve the thing that we wanted to achieve? And making that prediction ahead of time means that you're actually making good decisions, and at the end of the day, you're going to learn something. And sometimes we've killed programs. We've killed a lot of programs, in fact. Sometimes they're great programs, but they just didn't work out for different reasons. Usually it's a scaling reason, like, hey, this was a great idea, but we're going to go broke if we keep doing it, so we have to stop. And sometimes we just want to start over. But the best way to run an experiment is doing it cheaply. So this is, once again, Hawkeye looking adorable in the snow by my house in Chicago. Cheap experiments are great. You can learn a lot even if you don't put a lot of resources into it. In fact, if you go back through the history of Udacity as a company, there are a few times when basically the entire company was run on a couple spreadsheets and a couple of Google Forms, and we were manually tracking students as they were working, which was kind of crazy. But it gave us a lot of information. So I'm showing you guys something that nobody, I think, actually outside Udacity has ever seen before. This is our old content editor, our second generation content editor. It's ugly, it's difficult to learn, but it kind of works. So congratulations, you guys get to see it. It's better than the first one, though, and I'm going to tell you guys a really quick story about the first one. This is just kind of funny. I never got to use the first one because it was really, really terrible, and it looked a lot like this. And when we were making our first class, which was CS 101, Intro to Programming, one of our content developers at the time was trying to rearrange some videos. And so there was a little sidebar just like this one, and he clicked on it and started dragging. And the old content editor had this unfortunate feature where at the bottom of the screen was a trash can, and if you let go of a node on a trash can, it just got permanently deleted right then and there. And so he accidentally dragged and dropped about 2 months worth of work onto the trash can as he was trying to move it, and we lost 2 months worth of work. So I think there was some crying in the office that day. I've heard a lot about it. It's kind of funny. But anyway, so this is a lot better than the first one, but still there's some room for improvement. And the reason I bring this up is that the first nano degrees were actually just classes, and this content editor was made just to edit classes. We wanted to just try something out. So the first nano degrees were basically links to other classes within a class. And so the first students had to basically click on a link, it would open a new tab to a random other course, and all we had between them were like a couple videos explaining like why you're about to see a totally different class. And then we also had projects, of course. But this was a great experiment. We got to ask ourselves some really amazing questions and get data very cheaply. We asked ourselves, can we create a useful, longer experience for students, not just a class, but a whole collection of classes and projects? We've got to ask ourselves, can we scale this to make it maybe one day profitable, or at least see a way to get there? At the very least, we can't be losing a lot of money on it. And then we also got to ask ourselves, can employers get excited about hiring our graduates? And as it turns out, the answer to all these questions is basically yes. Yes, students found these longer learning experiences to be really helpful. It gave them a path forward. Instead of just taking an isolated class, we could give them a whole path to go from where they are now to where they want it to be. We did find that, yes, we can scale it. And we also found out that, yes, employers were really excited. In fact, we made our first nano degree with AT&T, which is a huge telecom company in the US. They built it actually for their own employees. They helped us with the front-end nano degree because they wanted their own employees to get better at front-end development. And we also had early graduates getting jobs at places like Google, which was just beyond our wildest expectations. We were so happy about that. And so these low-fidelity nano degrees gave us a lot of information. It was super cheap on our part. It just took a couple people and basically a couple weeks to put together. But we learned how we wanted to structure our nano degrees, what that really should look like, what a great experience would be. We got the data that we needed to polish the user experience, what students wanted to see. We got an understanding of what our content editor needed to support. And we also got confidence that when we were going to go forward and actually build these things out to what you just saw, that we're going to be doing it efficiently. This is our newest content editor, the 3rd generation one that we've been using for the last 2 years or so. Still not perfect, but it's a lot better. You can actually tell it's a lot nicer because I was able to zoom in on this one, and it still looks great. As opposed to the old one, I couldn't even zoom in on it because everything's absolute sized. And as a result, as a result of this experiment, we were able to go and build a first-class nano degree experience knowing that we were spending our resources wisely. Another experiment that we've worked on is project reviews. This is something that we did because we knew that, all right, well, if we're going to scale up these nano degrees with students submitting so many projects, how are we going to be able to give feedback on all of these projects? And we knew that there was no way we could do it all in-house. So we built a system where students could basically submit a project, and then somebody from around the world would give them line-by-line feedback on their code. And as of today, actually as of a couple months ago, we've had over 1 million projects graded, which is just an amazing thing, if you ask me. Students often cite this as a reason that they're taking nano degrees. Another fun experiment that we've done that I've been a part of is our career help. We help students. Nowadays, students can submit their resumes, their CVs, even cover letters to get feedback on them as they're preparing for new careers. We have this free career resource center if any of you guys are interested in trying to need some help with your resumes, for instance, to get a new job. Or CVs, I guess. I think those are more popular in Europe. But for the first resumes that got submitted from students as part of their nano degrees, we didn't have the review system. So what actually happened is one of my coworkers, Kathleen, took a stack of resumes, printed them out, threw them down on a table, and just got a bunch of red pens and handed them out to people and said, like, you come sit down and help out. And so we all just sat around a table, like physically marking up people's resumes, giving them feedback on it, and then just scanning them and sending them back. And obviously that's not scalable. Nowadays they go through our review system, but we wanted to learn, right? We wanted to find out, is this something that people find useful? And we found out that they did. And lastly, I think the biggest experiment of all is community. Now, how do we build an engaged community of learners? If you're in a school, if you're in university, you're sitting elbow to elbow with your classmates, and you can learn from each other. You have a professor who's probably just a few meters away from you, and you can talk to them. But online, it's not so different. But what you see, though, are all these amazing communities springing up online. You have Reddit, you have Twitter, you have Instagram, you have GitHub, you have Imgur, and I don't know, forums and chat rooms, and all these amazing ways that people collaborate online, even video games. We want to create one for education, and I'm not sure what that looks like yet. These experiments are ongoing. But for right now, it's fun to say that we have 50,000 students enrolled in nano degrees. These are people who are actively learning around the world. We have over 30,000 alumni, people who have graduated. We have thousands of students in jobs, and thousands of our previous students have gone back to give back to the community. They've gone back to help out current students. We also have localized programs. We're building nano degrees for people specifically in their regions around the world. We have offices in Sao Paulo, Brazil, I think New Delhi, India, Shanghai, China. We have an office in Berlin. We have a couple offices actually in the Middle East where we are building these experiences specifically for those people. And then lastly, one of the coolest that we're doing is something called Udacity Connect. And this one hasn't been rolled out that far, but basically it's a mix of in-person classes with online classes, getting students who are taking classes online to come together in real life to collaborate. And I'm curious to see how that goes. That is a very difficult experiment. Running a school is so hard. All right, so speaking of things that we're excited about going forward, I'd like to speculate a little bit. This is basically just me talking about what I would like to see in the future of education. So some of these are very original ideas, some of them are not, but here we go. So this is kind of fun. This is a video actually made by some Russian Udacity students. They did this on their own. They got scholarships from Google to study Android, and they just got to know each other really well online and decided to make this amazing video. It's a 6-minute music video. I'm just showing a small loop from it. I'm not sure what's about to happen, but it makes me laugh. I'm not sure what's going on there. But it's still amazing to see that people from around the world who didn't know each other before are coming together to learn. So what I'd like to see in the future of education are these spontaneous communities, people who don't know each other coming together to learn something new. And I'm not sure how long they should last, or I'm not sure what form they'll take, but I want to see them. Next up is virtual reality. You guys have already heard a lot about VR. Dale Naust gave a talk the other day about it. This is a video from Mission ISS, which is a game for Oculus Rift. And there are a lot of amazing opportunities for VR in education. Dale talked about using them, organizations using VR to train their employees on situations they may never see. I like to think of it as being an amazing opportunity for STEM classes, science, technology, engineering, and math classes. There's so many visual things that you can represent in VR. And then there are also opportunities for just new experiences that couldn't exist otherwise. I'm thinking about things like taking notes in VR. Like, can you imagine taking notes in a 3D space around you? Or could you imagine like maybe some kind of study aids, or just, who knows, like some kind of collaborative environment in VR where people are working together in ways that they just couldn't physically do in the real world. And that's really what I'm excited about. You can't just put 100 people in a virtual lecture hall and say that the job is done. There's a lot more to it than that, and I'm excited to see what happens. And lastly, I want to see more sabbaticals. Sabbaticals where somebody takes time off work to go do something. Usually professors take them. And I'd like to see that in the future, it's more accepted for people to take time off work, to take time away from their careers, to go learn something new, whatever that may be. Maybe you're working for a company who's sending you to a new country, and so you need to learn a new language. So you take 2 months off work to do an intensive course on it. Or maybe your company needs you to skill up. So they say like, hey, stop working, take 2 months, go learn this new thing that we need you to do. Or maybe you just take time off because you want to learn. You want to improve yourself through lifelong learning. You're just excited about it. There are a lot of reasons to it. And I don't think that any reason is necessarily better than another. But what I want to see is that people take the time out of their lives to do it. All right, and that's it. Thank you so much for being here. I really appreciate it. I appreciate everybody that I've met so far. You guys are just an amazing group here. There's some links here. I cited my numbers. I always like to do that. My blog and Twitter, I'll probably be posting these slides on Twitter later. And thank you so much for being here. I'll be outside answering questions later, so thank you.
Okay, so if you guys have any questions for Cameron, just raise your arm. Okay.
Hi, thank you for your presentation, even with this terrible weather. I was wondering what motivated you to start studying web development, and what was your starting point, and what would you have done differently now?
Oh, that's a good question. All right, so let's see, what motivated me? So I just thought it was really cool. I was like, all right, there's this thing that I interact with for hours a day called the internet, and I love the internet. I just want to know how it worked. It was pretty much as simple as that. And then what motivated me beyond that initial curiosity was just the rush that I got from solving problems. Like I studied physics for a reason. I just like solving problems, and these are really fun problems to solve. I like linguistics, I like language, I like writing, and I like logic, and that's basically a description of what programming is. And so that really motivated me to keep going. Let's see, then you had what would I have done differently? That's a good one. All right, so what would I do differently? I don't know. I mean, it's hard to say, right? Like, I don't regret anything. I think knowing what I know now, I still would have made the same decisions that I did then. Study more? I mean, I don't know, but you gotta have fun too. You can't just spend all your time in front of a computer. You gotta get outside too. Yeah, that's a good question. I don't know. Ask me later. I want to think about it.
Next question. Anyone else?
Just one more then. I was just reading your blog, and I noticed that you're React and Gatsby JS fan.
Mm-hmm.
I was wondering, like the JSX, the stuff like the reusable components and all of that. Like in the beginning, you said that you were not actually a fan of that. So, like, would you like if you knew it from the beginning, would you immediately go to it? Yeah, it's just like that's what I meant.
Sure. Okay, so the question is about JSX. So that's basically a mix of JavaScript and HTML that Facebook made up for its framework called React. I had an aversion to it at first. I didn't like it because I just thought it was so gross seeing my HTML in my JavaScript. It just like offended me. I was like how dare you do that? You know, like a little kid who sees like the peas on their plate touch the mashed potatoes, and now they don't want to eat either one, right? But I took a step back and then started to actually use JSX and then write these components, these composable components, especially using like a functional paradigm with it, and I actually just really enjoyed it. So yeah, knowing what I know now, I probably would have learned React earlier. So all right, that's one thing. I put it off for a long time. I stuck with other frameworks that I knew. I used Angular for a while. I also spent a lot of time using Polymer. I just thought that was really neat, which has sort of the same philosophy of like components, but without JSX. But yes, now I love it, and I'm not going to build any more websites without it until the next great thing comes out, and then I probably will just dump JSX as quickly as I dumped everything else.
Okay. One more question? No?
When I won the nano degree for front-end development, I remember saying to a friend of mine, I was super excited with the scholarship, and she just looked at me and she said, websites are totally over. The future is just apps. And that got me thinking, because I just enrolled in the scholarship for front-end web development. And I don't agree with her, not at all. What's your opinion on this?
Well, all right, that's a great question. So obviously I think that the web isn't going anywhere. I mean, everybody right now can take out their phone out of their pocket and access any company's website, like right off the bat. And if that company made their app designed for mobile, you can probably use it right off the bat, right? You don't have to download anything. I've heard some amazing stories of, for instance, from India, the company Flipkart, which is like Amazon in India. They've basically built this mobile experience so that even if you're on like the worst possible internet connection on your phone, you can still get on their website and buy things. You don't have to download, 50 megs worth of an app. You don't have to, even worry about like a couple megs worth of pictures showing up. It's like just a few kilobytes and you're buying online. So I think that the thing that the web has, the advantage the web has over native apps is that everybody already has it. And I think a lot of people for the last couple of years have been saying that apps are going to take over. App space is more valuable on phones than, for instance, your browser. But really the line has been graying between apps and the browser. People can build these amazing experiences that look like a first-class app. There's this idea of a progressive web app, mobile app, where you can basically download it to your phone. So anyway, long story short, no, I think the web's going to be around for a long time. Yeah.
Next question. Anyone else? Okay. So let's just give one more big round of applause for Grammar for his talk.